and thank you for watching the Unit 3 Koolaid Lab Class Connect recording. We are supposed to have this session March 4th at 2:30 p.m., but we are having some technical difficulties logging into the class, so instead I'm doing a YouTube video recording. The first thing that we needed to do was to watch this video related to a warm-up, and while you're watching this video, hopefully you can hear it, but if you can, I'll put the link for it in the description of this video. But while you're watching it, think about what's the solute, what is the solvent, and why does the salt dissolve. So let's take a look at it.
Let's add a small amount of table salt, sodium chloride, to water. As you know, sodium chloride dissolves in water. Click on the zoom button. Polar water molecules interact with the positive and negative ions of the salt. The positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between water and the salt ions causes the salt to break apart or dissolve in water.
Okay, so the answer to what is the solute, that would be salt. That's what is dissolving. What is doing the dissolving? What is the solvent? That would be the water. And why does the salt dissolve in the water? As he mentioned, the positive ends of the water, because water is partially positive on one side and partially negative on the other, was attracting the negative ends of the chloride, or the chloride, which is negative, and the negative ends of the water, which is near the oxygen, was attracting the positive sodium ions, and it was able to pull those ions away from each other. Our Georgia Performance Standard for today is SC7. Students will characterize the properties that describe solutions and the nature of acids and bases. So you need to open up your Koolaid lab, and that is available in the Unit 3 doc sharing folder as both a PDF and a document, or a Word document, and take a look at the activity, and you'll be able to fill out the activity as we go along. So the introduction and the materials section, the introduction says, and I'll read it for you, this activity introduces you to solutions and allows you to experience making different concentrations of Koolaid solution. There are many ways to calculate the concentration of a substance, including molarity, which is what we will be working with today, parts per million, percent composition, and grams per liter. In chemistry, concentration is usually measured by the number of moles of a substance per liter of the substance, or molarity. It's actually moles of the solute over liters of the entire solution. Okay, the materials that you need, so you need to make sure you have your Koolaid powder or whatever substitute that you decided on prior to completing this lab. And you could just use plain sugar if you don't have the Koolaid powder. If you do use Koolaid powder, you need to use the stuff that has the sugar already mixed in it, or it would just be nasty. Just be Koolaid mixed without sugar in it. Okay, you also need something to stir the solutions, 4 large cups, and a measuring cup, and then also dry measuring cups. So the first thing that we need to do, if you're taking a look at your Koolaid lab, let me open up the document on my screen as well so I can see it. The first thing you need to do is calculate the mass that you will need to make your first solution. You see in step 1, it asks you to make a 1 molar solution, and you need 237.5 milliliters of that solution. So let's talk about how to calculate the mass that you need in order to make your 1 molar Koolaid solution. And here's what you're given. You're given 237.5 milliliters. You are also given the concentration, which is 1 molar. One thing you have to know about this is that 1 molar really means 1 mole per liter of solution. So it's 1 mole per 1 liter. That's all that means. And then the molar mass of sucrose, you're also given that. That's 300 342 grams per mole. So basically we're going to use stoichiometry to get from liters to grams. So the first number I'm going to write down is the amount of solution I need, 237.5 milliliters. And I need to somehow get that number from milliliters and get to mass somehow, get to grams. Grams is the only unit that I need to be left with. So I'm going to look at the units that I have. I see I have moles per liter and I have grams per mole. Well, I can cancel out my milliliters using stoichiometry if I first convert that to liters. So what I'm going to do is say 1,000 milliliters equal to 1 liter. So there's my conversion factor. So now my milliliters cancel out. I have liters now. So I can look at my molarity and I see 1 mole is equal to 1 liter of this solution. So I'm going to put 1 mole over 1 liter of solution. So now my liters will cancel out and I'm left with moles. The last number I have is grams per mole. And remember, I'm trying to get grams and I'm trying to get rid of all the other units that I have. And so I want moles to cancel out and I want to be left with just the units of grams. So how can I do that? If I multiply by 342 grams per 1 mole, see now that there's a mole on the top and a mole on the bottom, so my moles cancel out. So when I plug this into my calculator, I type in 237.5 times 342 divided by 1,000. Hopefully this is right. And I get the number of 81.225. And I'm actually going to need 3 significant figures for this, so I'm going to write 81.2 grams. This is the mass that I need. So where it says grams of Kool-Aid needed, you'll write 81.2 grams. Okay? The molarity of the Kool-Aid needed is actually given to you in the problem. The molarity is 1 molar, right? So you see the blank that says molarity of Kool-Aid needed, you'll write 1 molar. And then liters of water needed. Basically, if you have 237.5 milliliters, how many liters do you need? You know, just to move the decimal place 3 places over to the left. So you would actually need 0.2375 liters of water. And then when it says to show your work, so I kind of worked my way backwards up your assignment, show your work, this is what you're going to show right here, some variation of this. So again, I went from milliliters to liters, liters to moles, and moles to grams. Using the numbers that were given to me in the problem, I could see which units I needed to cancel out and what units I needed to be left with, which were grams. So I have G left. So now you're ready to make your first solution. You know how many grams that you need, and we're going to just make the assumption that the number of grams you need is equal to 1/2 a cup of your Kool-Aid mixture. Let me look. Yeah, 1/2 of dry cups of your Kool-Aid mixture, and then you're going to mix that with 1 cup. So this is a different cup. It's not dry cup anymore. You're going to mix it with 1 liquid measuring cup of water. And then you're going to put that aside. You're going to taste test it later, but don't use it just now. So in your second step, let's see if it's on here. Oh, so liters of water needed, we said we needed 0.2375 units or liters. Molarity, remember, was given to us in the problem, which was I'm going to make more significant figures there. And then grams of Kool-Aid needed, we said, was 81.2 grams from our calculation we just saw. And this is what I just said here. You're going to measure out a half of dry cups of Kool-Aid and mix it with 1 wet cup of water, and then stir it together. Okay, your second step is the dilution. That's going to be your code word, and I will put the Class Connect survey attendance link in the description of this YouTube video. So if you need that attendance link, if you don't have it saved yet in your browser, then just click below the video in order to fill out the attendance survey. So let's talk about how to do a dilution. You'll need this equation, M1V1 is equal to M2V2. We've learned in previous unit that the 1 means initial and the 2 means final. And then your M, the big M, means molarity, and then the V means volume. So what we're trying to do with a dilution is figure out how much of the original substance we need, the volume of the original substance that we need in order to make our second solution. So what we're solving for is actually going to be V1. Alright, so our first solution, the molarity, M1, is equal to 1 molar, right? That's what we're making it from, 1 molar. And then our V1, that's our unknown, that's what we're solving for. So this is our question mark. M2 is the molarity that we want, which is going to be 0.5 molar. And then V2, we want 237.5 milliliters of the second solution. Now, we could do this in milliliters, or we can convert this to liters and do it. It's not going to make a difference as long as you know that whatever unit that you're using is the unit that you're going to end up with when you solve. So basically, if we use milliliters for V2, then it's going to be, when we solve it, we're going to be solving for milliliters for V1. So now all we have to do is rearrange M1V1 is equal to M2V2 and solve for our unknown, and then all we have to do at that point is multiply and divide our numbers that we have. So in order to solve for V1, here's the equation here, all we have to do is divide both sides by M1. So when we divide both sides by M1, the M1's cancel out over here. So let me rewrite that. V1 is equal to M2 V2 over M1. So now we can plug in our numbers. We know what each number is. This is going to be 0.5 times 237.5 milliliters divided by 1. So we don't even have to divide it by anything, because if we divide anything by 1, it's just going to be that number. So all we really need to do is say 0.5 times 237.5. Divided by, sorry, did I say divided by? I meant multiply, times 237.5 equal to. So 118.75 go V1 is equal to 118.75 milliliters. What we did, since this was 1 cup here, we know that 1 cup is equal to 237.5. All we did was divide that number in half. So really all we need to do is use 1/2 of a cup of the original solution. So in order to make your second solution, measure out, so you already have your Kool-Aid sitting there. They're really, well, I won't tell you if it's concentrated or not. Your first solution that you made, you need to measure out 1/2 cup of that solution, and then you're going to have to add another 1/2 cup of water to dilute it down. So basically we're cutting the concentration in half, which means that all we're doing is adding half a cup of the original solution and half a cup of water. That's all that means. Okay, so 1 cup of the 1 molar solution, add that to a half a cup of water, and you have your second solution. Second solution is going to have a molarity of 0.5 molar. So volume of 1 molar solution needed, we said that that was 118.75 milliliters, aka half a cup. And this is a wet cup. Okay, and then volume of water needed, same thing, half a cup. Or 118.75 milliliters. Okay? And I'm going to put this link for you. This is just another YouTube video where I demonstrate this for you. I'll put this link in the description box below so you can watch the demonstration, but this is also a part of your Word document that you will turn in. So you can just copy and paste that into your browser and you'll be able to watch a demonstration on how I do a dilution. Second dilution. We're now going to be using the 0.5 molar solution to make a 1 cup solution of 0.25 molar. Okay, so same thing that we did before in step 2. We're solving for V1. So V1 by itself is M2 V2 divided by M1. So V1 is our unknown. Our M1 is going to be 0.5 molar, because that's the solution that we're using to make our second solution. Okay. Our M2 is the molarity of the solution that we're making, which is 0.25 molar. And then V2 is how much of the solution that we want to make. We said it was 1 cup, and that is 237.5 milliliters. So plug the numbers that you have into your equation here. So that's going to be 0.5, just kidding, that's 0.25. There's no erase button on this thing. Just mark it out. Times 237.5. It's glitching a little bit, sorry about that. Divided by 0.5. So 0.25 times 237.5 divided by 0.5. So it's the same number that we got before. 118. So V1 is equal to 118.75. 1.8. I'll just rewrite it. Okay. And this is milliliters, and remember we said that that was just a half cup, right? So you're going to do the same thing. Since you have to use a half a cup, use a half a cup of the 0.5 molar solution and a half a cup of water. And when you add those two together, you will get your 0.5 molar solution. So we just said that this was 118.75 milliliters, 118.75 milliliters of water as well. So this is something that you actually have to fill out yourself once you make your solution. And it wants you, I can explain it to you, it wants you to relate the word strength to the concentration of the solution. So it's basically asking you, how strong is it? Explain the taste. Very strong taste, very weak taste. Over here you might want to say it is very concentrated, slightly concentrated, or dilute. So for this column over here, I'm looking for concentrated, so some type of word, concentrated or dilute here. You could say this is, very sweet or not sweet, depending on when you taste test it. And then this will be your 1 molar, the one that you start with. This will be 0.5 molar, and then this will be your 0.25 molar solution. And then you'll just insert your descriptions here in these blanks. Alright, and then we skipped over, if you look at the handout, let me look at it. I skipped over questions 1, 2, 3, 4, 5, 6, 7, and 8 because these are questions that we've discussed already. This is just your opinion, so you tell me which Kool-Aid solution you like the best, what was wrong with the other ones, what is the solute, hopefully you can figure that out, what's the solvent, what is molarity, so this is just asking you to list the units for molarity, or the definition of molarity. What is a dilution? So what did you perform in steps 2 and 3? What happened? Uh-oh, and I just answered that question for you. Alright, so number 9 is basically the only other one I feel like you should struggle with in completing this lab. So we're going to talk about that together. And we did go over calculating molarity on Wednesday of last week, so this is just a review for you guys. So A says if 1.8 moles of sodium chloride was dissolved in enough water to make 3.60 liters of solution, what is the molarity? So this is already in moles for us, so we don't even have to use the periodic table, which is really nice. So it's asking us for molarity, and there it goes glitching again, that's an M. And molarity is moles of solution over volume, or liters of solution, right? So we have our moles already. We'll just put that there. This is our solute. Our solution is going to be 3.6 liters. So all we need to do now is divide those two numbers. So let us look at our calculator. 1.8 divided by 3.6. So our molarity is 0.5. Molar. Okay, and the last problem, 9b, says if 20 grams of NaOH was dissolved in enough water to make a 250 milliliter NaOH solution, what is the molarity? So this is going to require that we use the periodic table. Well, if you weren't me, of course, but I know these. So the molar mass of sodium is 23. Oxygen is 16. And hydrogen is 1. So when you add those together, you get 40 grams. That is not 40. 40 grams per mole. So the first thing that we have to do is convert grams to moles, and then we also have to convert milliliters to liters, and then all we have to do is divide those two numbers. So in order to get the top number of our molarity, let's write the formula for molarity, moles over liters. To get the top number, we have to say 20 grams divided by 40. So we're going to get 0.5 moles. So there's our top number. Our bottom number just requires that we change milliliters to liters, so move that decimal place over 3 places to the left. So our bottom number is going to be 0.250 liters, and then we just divide the two numbers. So we have 0.5 divided by 0.25 going to equal our molarity. So our molarity is equal to I know this is 2, but I just wanted to double check. Okay. Is equal to 2 moles per liter. Okay, I think that's all we have to go over. If you have any questions, let me know. And make sure you just turn it into the Dropbox when you're finished. I will talk to you guys later. Have a good day. Bye-bye.